to convince you that this is exactly what's happening in R every single time you run a regression, I want to do this by hand and really break down exactly what's going on, as well as creating our own data so that we know exactly what the data generating process is. So you can see here, I'm just creating data in line 2. I'm setting my seeds so that you can reproduce it yourself. Now in line 3, that's just the vector of errors. Remember, again, our assumption is that they have to have a mean of 0 and they're coming from a normal distribution. So I'm just taking 100 random observations from a normal distribution. They have a standard deviation of 1. So now we know exactly what the variance of the errors should be. I'm then creating 2 different covariates in our matrix of X, and I'm also filling the first column with all ones. Remember, that's how our matrix of covariates is constructed. Then I'm finally making our outcome Y, which is a function of our covariates as well as our error terms, and I'm forcing the relationship between x1 to be 5. That should be what the actual relationship is. And then the second one is 2.75, and I'm saying that the y-intercept should be 10. Now, in line 8, we can take that equation from before that we talked about and actually calculate our estimated betas. We get an estimated slope for the first covariate of 2.77 and an estimated relationship with the third of 0.005. Our y-intercept is estimated at 14.56. Now let's check to make sure that we actually did that correctly. We can use the shorthand in R with just LM. Y is our outcome, and then we have our first and second covariate, which are in the second and third columns of our X matrix. And here I'm just taking the covariates from that estimated linear regression. And again, we can see that our intercept is 14.5 approximately. Our beta for our first covariate is 2.77, and the beta for our second covariate is 0.005. Now that we have our estimated coefficients, let's construct the standard errors, or the bounds of uncertainty around those estimates. So if you remember, the first thing that we're going to need is an estimate for our sigma squared. And I'm not going to recount what that equation is, but here you can see in line 2 that that's essentially all that I'm doing. Is I'm taking the difference between our outcome Y minus X times those new estimated betas. And again, we don't care about what direction we're going in, so we're taking the sum of the squared deviances, and then we're dividing by, again, the number of rows, which is n, the number of observations, minus the number of columns, which is the number of covariates minus 1. That results in 0.89, or around 0.9 approximately. And again, we want to check that we got that right so we can run our regression again. This time, we're just putting summary around our regression model. And from summary, we're just looking at what the estimated sigma squared is. And lo and behold, we get the exact same thing. With our estimate of sigma square in hand, now we can go ahead and actually estimate our covariance matrix, which you'll remember that the diagonals of which, if we take the square root of, that's going to give us the standard error of our betas. So again, I'm not going to go over this formula, but essentially I'm just executing this in R so that in return we get a 3x3 matrix, which the diagonals of which, if we take the square root of, we'll get the standard error of our estimated betas. And we want to make sure that we're getting this right, and like all things in R, there's an easy and a hard way. I've done it the hard way. The easy way is just getting the variance covariance matrix, so we can just do v-cov of our model, and we get the exact same thing back. So to calculate the standard errors, all we're going to do is take the square root of the diagonal of that matrix and we get 0.53 about, 0.02 about, and 0.0099. And again, we can check that in R very easily. One, by kind of doing the exact same thing that we just did by taking the square root of the diagonals of the variance covariance matrix. Or what's easier is we can just take the summary of our model, and the second column of that summary is going to give us the standard errors. And so again, we can see that we did this correctly.